Modern pig farms, raising pigs entirely on farms, have become a popular trend in many countries around the world. For the United States, which tops the list of global pork production, modern pig farms are often equipped with advanced automation systems, including feeding, cooling, and waste treatment systems. China, the second-largest pork-producing country, also applies this model on a large scale with the integration of advanced technology. Brazil, the leading pork producer in South America, has modern pig farms, often built in temperate climates. The European Union, EU, is one of the major consumer markets, and modern pig farms in the EU comply with food safety and environmental protection standards. More importantly, the process of raising piglets for the first time is an important stage, and mother's milk is the most valuable source of nutrition. Breast milk contains adequate protein, fat, lactose, vitamins, and minerals needed to support the comprehensive development of piglets. After weaning, piglets are cared for by providing nutritious bran mixed with water. An automatic feed and water supply system for a piglet farm costs around $100,000, 0 cents, to $200,000, 0 cents, depending on the size of the farm. And includes a feed mixer, piping system, feeders and drinkers. Some advanced pig farms practice planting trees to filter the air. However, this may require high construction costs due to special requirements such as a large enough area, suitable tree selection, and maintenance costs. Although it may increase operating costs, benefits include reduced environmental pollution and reduced noise on the farm, creating a healthy living environment for piglets. Pig transportation technology is also improving. With the rack support system to transport pigs onto trucks, people's effort has been greatly reduced. Early morning is the best time to transport pigs. Cool temperatures help pigs feel more comfortable during transportation. This vehicle can transport about 50 to 100 pigs in one trip. Pigs, after being brought to the processing factory. They will go through many processing steps until large pieces of carcasses are harvested. The pork carcass is put into a cooling room to cool down to 0 to 4 degrees Celsius, preventing the growth of bacteria. Then, the pork carcass is transferred to the conveyor belt and moved to the cutting position. The cutting blade is controlled by machinery, automatically cutting the carcass into parts such as shoulder meat, rump meat, tenderloin meat, carcass, and pork belly. The meat parts are transferred to other conveyors to continue being chopped into pieces of meat according to the required size. Then the meat pieces are sent to the packaging machine to be packed into bags or boxes. Each day, the factory can cut between 1,000 and 2,000 pieces of carcasses, depending on the capacity of the cutting line, the size of the carcass, and the number of workers. After being chopped, the meat pieces are sent to the packaging machines. Types of packaging machines include vacuum packaging machines, blister packaging machines, and blister vacuum packaging machines. These devices help tightly pack pork, pulling all the air out of the bag or box to better preserve and transport the meat. Regarding the price of pork raised on modern farms, it depends on many factors such as feed prices, veterinary service prices, labor prices, and gasoline prices. Normally, the price of pork ranges from 2.5 to 3.5 USD/pound. The production line for bacon from rib meat is a complex process that includes key steps to create the final product. First, the rib meat is prepared, removing the skin, excess fat, and unnecessary edges. This edge of meat is often used for products such as sausages or ham. Next, the rib meat is sprayed with colored water to create an attractive color and flavor. The colored sauce is made from natural ingredients such as sugar, honey, soy sauce, and spices, making the meat appear more attractive. The ribs are then brought into the smoking room where wood such as oak, mesquite, or hickory is used to create the characteristic flavor. Meat smoking time usually lasts from 6 to 8 hours, depending on the thickness of the meat and the desired level of smoking. The bacon is then cut into thin, bite-sized pieces before being packed into vacuum-sealed bags or boxes for long-term storage. Every day, a modern line can package about 1,000 to 2,000 products per day, with prices ranging from 20 to 30 USD/pound, depending on factors such as type of meat, type of smoking wood, and brand. The sausage processing process with a modern and automatic processing line is carried out through a series of specific steps. First is the process of preparing the ingredients, in which the meat, fat, and spices are washed, pureed, and then mixed well. The meat mixture is fed into the sausage extruder to shape the product. After that, the sausage is steamed again to ensure even cooking and delicious flavor. Next, the sausage is cooled to make it easier to cut into pieces, then cut and packaged into bags or boxes for storage and transportation. Every day, a modern sausage processing line can produce from 10,000 to 20,000 sausage packages per day. Prices range from 1 to 3 USD per package, depending on these factors. If you're concerned about nutritional value, hot dogs provide large amounts of protein and iron, but are also high in saturated fat and sodium. Therefore, limiting sausage intake is important to avoid health problems such as obesity, cardiovascular disease, China processes over 1.2 million tons of black pork annually, with key regions such as Sichuan, Guangdong, and Hunan leading production thanks to their expertise in blending traditional and modern techniques. As highlighted in many farming documentaries, the meticulous processing of black pork often involves advanced traceability systems to guarantee quality and authenticity. Prized for its marbling and rich flavor, black pork requires slower, more precise processing than regular pork, emphasizing small batch marinating and premium cuts. Advanced technologies like vacuum sealing and modified atmosphere packaging are used alongside traditional methods to preserve the meat's distinctive flavor and extend its shelf life. Unlike regular pork, black pork processing focuses on manual craftsmanship and branding, solidifying its reputation as a luxury product in domestic and global markets. In China, over 154,000 tons of black pork, about 70% of production, is distributed through traditional markets, particularly in regions like Sichuan, Guangdong, and Hunan, where the meat is a local staple. Butchers in these markets emphasize manual processing to maintain freshness and quality, often selling over 1,100 pounds weekly. Consumers value selecting specific cuts, often referencing farming documentaries that highlight the meat's superior marbling and flavor. However, challenges include maintaining hygiene and quality, especially in warmer regions, where limited refrigeration can shorten shelf life. Some butchers report price sensitivity, as black pork is 20 to 30% more expensive than standard pork. Despite this, loyal consumers appreciate its rich taste and cultural significance, ensuring consistent demand. The breeding season of black pigs is carefully managed by Chinese farmers to ensure high-quality offspring and meet the growing demand for their premium meat. Black pigs typically have a longer gestation period of about 114 days, similar to ordinary pigs. But their reproduction rate is lower, with litter sizes averaging 6 to 8 piglets, compared to 10 to 12 in standard breeds. However, black piglets are distinct due to their robust build, darker skin, and higher resistance to diseases, making them more resilient in varying farming conditions. Farmers in the farming documentary often highlight the slower growth rate of black pigs as a trade-off for their superior marbling and flavor. This meticulous breeding process reflects the commitment to maintaining the quality that distinguishes black pork from regular pork. To ensure the sustainable development of black pigs, Chinese farmers are increasingly adopting integrated farming models that integrate crop and livestock farming. On average, farms dedicated to black pigs are 5 to 15 acres in size, with an initial investment of $50,000 to $150,000, depending on the scale and technology used. This model allows farmers to use crop residues as feed, reducing costs while providing a natural diet that enhances the quality of black pork meat. Scientific research has emphasized that black pigs thrive in free-range environments, requiring more space and a more natural habitat to express their foraging behavior, which contributes to the development of lean muscle and marbling. But that does not mean that farms do not develop suitable housing for them. Integrated farming models are quite popular and promote sustainability by recycling waste into organic fertilizer for crops, creating a self-sustaining ecosystem. The approach in these farming documentaries helps consumers to choose high-quality and environmentally friendly pork products. In China, black pigs are fed a specially designed diet that includes grains, vegetables, and food industry byproducts, which farmers cook to create a nutritious meal. These pigs are also given regular baths in natural or artificial pools to maintain their health, especially in warmer climates. Bathing helps regulate body temperature and reduces the risk of diseases. Additionally, some farmers organize swimming activities in shallow ponds to support muscle development, a practice that aligns with the natural instincts of black pigs. This unique nutritional and care regimen is highlighted in farming documentaries, showing how such methods contribute to the marbling and flavor of black pork. On average, farmers spend about $5,000 annually on feed and care for each pig, reflecting the investment needed to produce high-quality meat. The U.S. livestock industry, valued at over $75 billion annually, once relied on manual labor for feeding, milking, and health monitoring. limiting a farmer to managing around 50 animals efficiently. Before automation, dairy farmers spent up to 60 hours a week on milking alone. But today, robotic systems reduce labor time by 50% while increasing milk yield. With AI-driven monitoring and precision feeding, farms now optimize nutrition, cut waste, and boost productivity. This farming documentary explores how cutting-edge technology is reshaping American livestock farming for a more efficient and sustainable future. For centuries, livestock farming relied on human labor, simple tools, and traditional practices like manual milking and hand feeding, limiting efficiency and production. Industrialization changed everything. By the 1950s, mechanical feeders reduced feeding time by nearly 30%, easing farmers' workload. The 1980s brought automatic milking machines, allowing a single unit to milk up to 70 cows per hour, revolutionizing dairy farms. Since the 2000s, AI-driven health monitoring, robotic milkers, and precision feeding systems have boosted productivity by over 25%, optimizing farm management. While modern technology increases efficiency and sustainability, it also raises concerns about costs and small farm viability. This farming documentary explores the dramatic transformation of livestock farming, contrasting traditional labor-intensive methods with cutting-edge automation shaping the industry's future. Modern dairy farming has been transformed by automated milking systems, which use robotic arms to milk cows with minimal human intervention. These machines allow cows to be milked on demand, reducing stress while increasing milk yield by 10 to 15% compared to traditional methods. By eliminating the need for manual milking, farmers save up to 50% in labor costs and gain real-time data on each cow's health and milk quality. Since installing robotic milkers, my cows are calmer, production has increased, and I spend more time managing the farm instead of milking, says dairy farmer Mark Reynolds. This breakthrough technology is reshaping the industry in farming documentaries, making dairy farming more efficient, sustainable, and profitable than ever before. Smart feeding systems are revolutionizing livestock farming with automated dispensers and AI-driven sensors that provide precise nutrition based on each animal's needs. These systems dynamically adjust feed composition, optimizing growth, milk production, and overall health, while reducing waste by up to 20%. By preventing overfeeding and underfeeding, farmers can save up to 30% on feed costs and ensure healthier livestock. Automated feeders also monitor consumption patterns, detecting early signs of illness. This farming documentary explores how smart feeding technology is transforming farm efficiency, cutting costs, and paving the way for a more sustainable and profitable future. In the farming documentary Automated Manure Management Systems, including robotic manure collectors and waste-to-energy solutions, are revolutionizing farm sanitation and sustainability. These systems remove waste efficiently, keeping barns cleaner, reducing odors, and minimizing disease risks, all while cutting labor demands by up to 60%. Advanced digesters convert manure into biogas and organic fertilizer, turning waste into valuable resources. With automated manure management, we've reduced farm emissions by nearly 40% while improving hygiene and efficiency, says environmental expert Dr. James Carter. By integrating automation, livestock farms can enhance sustainability, lower pollution, and create a cleaner, more productive farming environment for the future. In the next installment of the farming documentary, livestock monitoring and AI technology are transforming herd management with wearable sensors and AI-driven analytics that monitor animal health in real time. These smart devices measure vital signs, activity levels, and feeding behavior, allowing farmers to detect disease early and prevent major losses. Since implementing AI monitoring, we have cut disease-related losses by 25%, says dairy farmer Sarah Mitchell. On a Wisconsin dairy farm, technology isn't just boosting production, it's changing lives. Before automation, we were exhausted, working long hours just to keep up. Now smart feeding and robotic milking have increased our milk production by 25% and cut our labor costs in half, says farm owner Tom Reynolds, his voice filled with relief. With AI-powered monitoring and automated manure management, His cows are healthier and his farm runs smoother than ever. This farming documentary takes you inside real farms, where hard work meets innovation, proving that technology isn't just changing agriculture, it's securing its future. New Zealand is the world's largest deer farming country, with an industry that has grown since the 1970s. Today, the country has around 1 million deer, produces over 12 million tons of venison annually, and exports over $65 million worth of antlers. Popular breeds include red deer, sika deer, rusa deer, and wapiti, which are farmed for meat, velvet, and leather. In many farming documentaries, New Zealand has also pioneered advanced breeding techniques, artificial insemination, and software-based herd management, ensuring high productivity and quality products. While Russia, China, Canada, and the United States have developed deer industries, New Zealand remains a global leader in scale, technology, and innovation. The hidden economy of deer farming operates through two main models: open-air sanctuaries and rural deer farms, each of which caters to different markets. Open-air sanctuaries, typically 1,000 to 5,000 acres, provide a semi-wild environment where large bucks are bred for high-end hunting preserves, with guided hunts costing between $5,000 and more than $50,000 per deer. In contrast, rural deer farms, typically 50 to 500 acres, focus on intensive breeding for venison, antler production, and live animal sales, contributing to the $7 billion U.S. deer industry. Reserve farmers praise the high profits from hunting, while ranchers emphasize the steady income from exporting meat and antlers. However, through farming documentaries, it can be seen that reserves face ethical debates over canned hunting, while ranchers struggle with disease control and strict regulations. Despite their differences, both models demonstrate the diverse economic potential of deer farming. Selective breeding and genetic engineering are transforming deer farming, allowing scientists to enhance antler size, body structure, and disease resistance through advanced genetic selection. In this farming documentary, researchers now use DNA analysis and AI-driven modeling to identify superior traits. With one geneticist stating, "We can now predict the potential of antlers before a deer is born." While this technology boosts profitability and herd quality, it raises ethical concerns. Are we pushing nature too far? What happens when wild deer mate with genetically modified farmed deer? Conservationists warn of genetic homogenization and unforeseen ecological impacts, sparking debate over the limits of science in wildlife management. Veterinary care on deer farms and sanctuaries is a high-stakes balancing act, where disease prevention is just as important as genetic and nutritional management. Chronic wasting disease, CWD, a neurological disorder, is a silent threat to the industry. Spread through contaminated soil, saliva, and even deer urine. Yet few outside the industry talk about it. How do farmers protect their multi-million-dollar herds from an invisible enemy? As one veterinarian specializing in deer health explains, one case of CWD can shut down an entire operation. The footage you're watching in this farming documentary reveals the silent battles behind the fences. Could these farms inadvertently cause a future epidemic? Please express your opinion in comment 1 if you have one. Proper nutrition is a critical factor in deer farming, directly impacting growth rates, antler development, and overall health. Unlike traditional livestock, deer have a slow growth period, requiring a precise balance of protein, minerals, and energy-dense feed to reach their full genetic potential. Advanced nutritional analysis helps farmers optimize diets with high-protein forages, supplements like calcium and phosphorus, and specially formulated pelleted feeds. In farming documentaries, the nutrition expert explains, proper nutrition can make the difference between a $10,000 deer and a $500,000 deer. With the right diet, deer grow larger, healthier, and more valuable, maximizing returns in this high-stakes industry. Once farm deer reach 250 to 350 pounds, they are carefully selected for processing based on muscle quality, fat composition, and overall health. Deer fed a high-protein diet and strict biosecurity protocols produce leaner, higher-quality venison that is in high demand in high-end restaurants, specialty markets, and for export worldwide. Only the top animals meet processing standards, with meat yields exceeding 60% of body weight and premium cuts costing $25 to $50 per pound. In factory farming documentaries, the process includes stunning, skinning, and precision cutting of the meat into steaks, roasts, and ground venison, with the U.S. venison market valued at more than $150 million annually. With consumer demand for organic lean meat on the rise, could venison be the future of sustainable protein?